Today we are going to start with and talk about expected value. Expected value is also sometimes referred to as expectation. And what expected value is it determines the expected results of an experiment or business over the long term. So when we're thinking about our expected value, this is not something if we were to try this once or think about something for a very short period of time. We're looking at something over a very long period of time. Expectation or expected value is commonly used by insurance companies. It can also be used to make other predictions about expected gains or loss in general, such as the lottery, roulette, craps, and slot machines. All right, our rule for expected value is pretty simple. We do see some subscripts here, but the idea is that we're going to take our probability of each different event occurring times the net amount that is either won or lost for each event. All right, so in this first example, JetBlue Airways is considering adding a route to the city of Minneapolis, Minnesota. Before the company makes its decision as to whether or not to serve Minneapolis, it needs to consider many factors, including potential profits and losses. Factors that may affect the company's profits and losses include the number of competing airlines, the potential number of customers, the overhead costs, and fees it must pay. All right. After considerable research, the company estimates that if it serves Minneapolis, there is a 60% chance of making a $900,000 profit, a 10% chance of breaking even, and a 30% chance of losing $1,400,000. How much can JetBlue Airways expect to make on this new route? Right, so as we are going through and working through this problem, again, we are thinking about our expected value over the long term. Our rule, which we can still see at the top, right, we're taking our probability of each event times the net amount for each different outcome. All right, so in this case, right, we're going to, we do have 3 different possibilities of things that are happening. Right, so our rule is going to look like E equals P1 times A1 plus P2 times A2 plus P3 times A3. Right? So our expectation for this particular example, there is a 60% chance of making a $900,000 profit. So 60% as a decimal is 0.60 times our amount, which is 900,000. Our next event, there is a 10% chance of breaking even. So 10%, 0.10 times breaking even means no money is won or lost. So we're going to take that 10% times 0. Plus our 30% chance of losing $1,400,000. So this is going to be 0.30. And then since we are losing money in this case, we're going to multiply it by a negative number. So negative $1,400,000. As we go through and we do the math, right, we're going to multiply these first two together. Our middle term is going to cancel out because anything times 0 is just 0. Over here, we're going to get a negative number. And this is going to give us 120,000. So in this particular example, JetBlue has an expected value, right, an expected average annual gain of $120,000 for this particular route. So we're going to say JetBlue has an expectation of $120,000 for this route. We're going to work through a few more examples. Our next example, we are going to look at some test-taking strategy questions. So in this next example, Maria is taking a multiple choice exam. In this multiple choice exam, there are 5 possible answers for each question. The instructions indicate that she will be awarded 2 points for each correct response. She will lose 1/2 point for each incorrect response, and no points will be added or subtracted for answers left blank. So, in example A, says if Maria does not know the correct answer to the question, is it to her advantage or disadvantage to guess at an answer? Right? So we need to figure out what we are looking at here. What are our different possibilities and our probabilities associated with those? Right? So one possibility is that Maria guesses correctly. Right? Our probability of guessing correctly, right? There are 5 possible answers. Each question has exactly 1 correct answer. So our probability of guessing correctly is 1 out of 5. Our probability of guessing incorrectly. Our probability of guessing incorrectly is going to be 4 out of 5. Okay. So using our formula, this time we have 2 different events. So E is going to be P1 times A1 plus P2 times A2. Okay. And our probability of guessing correctly is 1/5. Okay. If we make a correct guess, we are awarded 2 points. Our other probability is 4 out of 5. And if Maria guesses incorrectly, right, she loses 1/2 point. So again, because she is losing, it is a negative number. If we multiply these together, right, if we think about this 2 as a fraction as 2 over 1, right, when we're multiplying fractions, we multiply straight across, numerator times numerator up top, the denominator times denominator in the bottom. Right, so we have 2 over 5, because 1 times 2 is 2, and 5 times 1 is 5. And then multiplying our other fraction, we're going to have minus 4 out of 10. Right? Again, the minus sign coming from our negative 1/2. 4 times 1 is 4, 5 times 2 is 10. We can then at this point reduce, plug these into your calculator. Even if you want to plug them into your calculator from the beginning, that's fine. 2 over 5 was our first fraction. Our second fraction, negative 4 over 10, actually also reduces to 2 over 5. And if we subtract these, we get a 0. Right? So in this case, is it to her advantage or disadvantage to guess at an answer? Her expectation is 0. So her expectation is 0. She will neither gain nor lose points by guessing. Right. So our example A, our answer, expectation again is 0. So in this case, she will neither lose nor gain points just by simply guessing. Right. For example B, right, if she can eliminate one of the possible choices, is it to her advantage or disadvantage to guess at an answer? Right. So first we're going to look at our probability of guessing correctly. Right. So if she eliminates one of the answers, then there is only 4 left. So she has a 1 in 4 chance of guessing the question correctly. Maria's probability of guessing incorrectly would be 3 out of 4. Right? In both of these cases, in example A and example B, our probabilities of guessing correctly and incorrectly are complements of one another. Right? So one is that an event will happen, the other one is the event does not happen. Right? Again, we have 2 different possibilities. So our formula is still P1 times A1 plus P2 times A2. Right? So we're going to go through and we're going to multiply our probabilities. So our expected value, probability of guessing correctly is 1 out of 4. Still 2 points awarded if Maria guesses correctly. Our probability of guessing incorrectly is 3 out of 4. And in this case, she still loses 1/2 of a point. So again, we're going to think about this 2 as being a fraction, and we're going to multiply across. Right? 1 times 2 is 2. 4 times 1 is 4. So we have 2 over 4 minus 3 over 8. Then if we change this to fractions that have like denominators that we can subtract, our 2 over 4, we'd have to change to a fraction that has a denominator of 8. So we're going to multiply both our numerator and denominator by 2. So we have 4 over 8 minus 3 over 8, which leaves us with 1 over 8. Okay. So in this case, her expectation is 1/8 of a point. So is it to her advantage or disadvantage to guess at an answer? Well, we would say it would be to her advantage to guess at an answer. Right? It's at her advantage to guess because Maria will gain, right, 1/8 of a point for each correct guess. So again, in example A, her expectation was 0. So there was neither a gain or a loss, neither an advantage or disadvantage. In this case, her expectation is positive. It's 1/8, so it would be to her advantage to guess. Right, moving on to example 3 then. Example 3, we're going to look at expected attendance at an outdoor event. So for an outdoor concert, event organizers estimate that 20,000 people will attend if it is not raining, and only 12,000 people will attend if it is raining. On the day of the concert, meteorologists predict a 30% chance of rain. Determine the expected number of people who will attend this event. So again, we're going to start with our probabilities. So our probability of rain, we are told, is 30%. As a decimal, 0.30, and our probability of it not raining, again, we're thinking complement, right? So it needs to add up to 100% as percents, it needs to add up to 1 as a decimal, so this would be 0.70. So again, we have 2 different events that we're looking at. Right? So our formula, P1 times A1 plus P2 times A2 for our expected value. So we're going to have a 30% chance of not raining. So we're going to multiply, a 30% chance of raining. So we're going to multiply that 30% times the attendance of 12,000 people if it does rain, plus 0.70 times 20,000 if it does not rain. So as we work this out, we get 3,600 plus 14,000, which gives us an expected attendance of 17,600 people. So the expected number of people who will attend is 17,600 people. So a couple of different types of examples. One looking at a business venture over a long time. One looking at the chances of guessing correctly to questions on a quiz. Right? And then the last one, expected attendance at an event based on different cases of weather. The next couple of examples that we're going to go through, we're going to look at some different cases of winning prizes. And as we're looking at these examples, what is the expected value or expected amount that we're going to get if we compare these different events? So in example 4, Josh attends a charity event. Right? And at this charity event, in example A, he is given a free ticket for the $50 door prize. A total of 100 tickets will be given out. So we want to determine his expectation of winning the door prize. Right? So he is given exactly 1 ticket. Right? There are 100 tickets that are given out. So his probability of winning is 1 out of 100. His probability of losing, again, we're thinking complements. They need to add up to 1 whole. Right? So if he has a 1 in 100 chance of winning, well, he has a 9 in 100 chance of losing. Right? So his expected value, again, is going to be P1 times A1 plus P2 times A2. So we are going to take 1 out of 100 for his probability of winning times winning a $50 prize, so times 50, plus probability of losing 99 out of 100. And in this case, he hasn't invested any money, and he just simply is not the winner, so he doesn't win or lose anything. So our amount for that second probability is 0. So this gives us 50 over 100 plus 0, because that second multiplication cancels out, which gives us 1 out of 2, which this time we're thinking money. So instead of leaving our answer as a probability, we're going to change this to a decimal, and we're going to say that his expected value in this case is 50 cents. Right, for B, the difference between A and B. In A, he is given a free ticket. Right? In B, he has to pay for his ticket. Right? So our probability of winning and losing are still going to be the same. Right? So we still have a 1 in 100 chance of winning that $50 door prize. Right? And our probability of losing is still 99 out of 100. So we're still going to use the same formula. E equals P1 times A1 plus P2 times A2. Okay, the only difference is there's going to be a slight change in the amounts for our formula for this case. So our probability of winning, Josh still has a 1 in 100 chance of winning the door prize. However, the amount that he is winning is not going to be $50 like it was in example A. Instead, his amount is going to be whatever he wins minus the cost of what he purchased. So if he wins $50, but he actually spent $2 on the ticket, right, his net gain is going to be $48. So we're going to take our 1 out of 100 times 48. Right. Josh's probability of losing is still 99 out of 100. Right. And this time, if he loses, since he spent the $2, he actually is losing $2. So we're going to have a -2. Right. So again, because he actually had to buy the ticket this time, right, he doesn't win the full 50, he wins the 48, he wins the difference. If he loses, right, he's out the $2 that he spent on the ticket. Right. So 1 over 100 times 48 gives us 48 over 100. Right. Our next number is going to be negative. 198 times 2, excuse me, 99 times 2 gives us 198. Which then if we subtract, we get negative 150 over 100, which then we turn it into a decimal for a dollar amount, and his expected value is negative $1.50. So again, the big difference between A and B is that in example A, he didn't have to spend the money. Right? His expected value was a gain of 50 cents. In example B, he did have to spend $2 on the ticket. His expected loss in this case was $1.50. Example 5, we're going to set up somewhat similarly. Again, we're looking at an example where we are considering raffle tickets. So 1,000 raffle tickets are sold for $1 each. One grand prize of $500 and 2 consolation prizes of $100 will be awarded. The tickets are placed into a bin. The winning tickets will be selected from the bin. Assuming the probability that any given selected ticket for the grand prize is 1 out of 1,000, the probability of selecting a consolation prize is 2 out of 1,000. We're asked to determine a couple of different things. So first we're going to figure out Irene's expectation if she purchases 1 ticket, and then find her expectation if she purchases 5 tickets. So our first probability that we're looking at here is our probability of winning the grand prize. So our probability of winning the grand prize is 1 out of 1,000. 1,000 tickets are sold, and there is 1 grand prize. Our probability of winning one of the consolation prizes. We're told that 2 consolation prizes of $100 will be awarded, so that is 2 out of 1,000. Both of those are also given to us in the last sentence of the problem. We also need to consider in this case the probability of not winning either. So if we look at this, we have 1 grand prize, 2 consolation prizes. So total out of 1,000, that's 3 different prizes that are being given out. So our probability of losing or not winning either of these prizes is going to be 997 over 1,000. This time when we set up our formula, E is going to be P1 times A1 plus P2 times A2 plus P3 times A3. So our probability of winning the grand prize is 1 out of 1,000. Right. Our grand prize is $500. The tickets cost $1. So the net gain in this case is $499. Probability of winning a consolation prize is 2 out of 1,000. In this case, our consolation prize is $100. Again, we spent $1 on the ticket, so that means a net gain of $99. And the probability of not winning either is 997 over 1,000, right? Times, in this case, we're losing the $1 that was spent, so we're going to multiply it by a -1. All right, so we end up with 499 over 1,000 plus 198 over 1,000 minus 997 over 1,000, which then if we add and subtract, we get -300 over 1,000, which if we turn it into a decimal is -30 cents. So if Irene buys 1 ticket, she has an expected value or an expectation of -30 cents. Our answer to B, once we have the answer to A, is quite simple. Find Irene's expectation if she purchases 5 tickets. Well, we're simply going to take 5 times her expectation for buying 1 ticket. So we're going to take 5 times our -30 cents, which gives us an expected value or expectation of -$1.50 if she buys 5 tickets. The last types of examples that we're going to talk about, fair price. When we're working through these questions for fair price, we are going to have to take our expected value into consideration. Our fair price is the amount that will be paid that will result in an expected value of 0. So in order to find our fair price equals our expected value plus our cost to pay. So looking at example 6, we're going to use that formula that we just looked at above, and we're going to use the spinner as a guide for this question. So suppose you are playing a game in which you spin the pointer shown in the figure. If it costs $8 to play the game, determine the expectation of a person who plays the game. All right, so the first thing we need to do is figure out our different probabilities. So looking at our spinner that we have over here, we have exactly one little wedge here, right, that's $20. And if we think about this spinner, right, we could imagine if each one of these $1 and $5 spaces were cut into half, then we would have 8 pieces total, 8 equal pieces. So our probability of winning $20, since it's one of our small equal pieces, right, would be 1 out of 8. Our probability of winning $10 is also one of these small pieces, so that it is also 1 out of 8. Right. Our probability of winning $5. Right. If we look at that, that is the bottom fourth of the wedge, so that is going to be 1 out of 4. Or if you want to write it using eighths as well, we could write it as 2 over 8. And our probability of winning $1, right, we have 2 wedges out of the 4. Right? So 2 out of the 4, which then again, if we want to consider it as a fraction with a denominator of 8, we could write it as 4 over 8. So again, our piece for $10 and $20 are each 1/8 of our circle. Our probability of winning $5 is this bottom wedge, which is 1/4 of our circle. And then we have 2/4 or 1/2 or 4/8, right, is our probability of winning $1. All right, so to find our expected value, we're going to have 4 different products to find. So our probability of each different amount times the amount that they would win. So let's look at winning $20 first. So we have a 1 out of 8 chance of winning $20. We spent $8 to play. So if we win $20 but we spent 8, we have a net gain of $12. Our next event, winning $10, we also have a 1 out of 8 probability. In this case, we won 10 but we spent 8, so we really only came out $2 ahead, so we had a gain of 2. There is a 1 out of 4 or a 2 out of 8. I'm going to use a 2 out of 8 so that way I have common denominators. Right, so our 2 out of 8, this time if we win $5, well, we spent 8, so we're actually losing $3. So we're going to multiply that by -3. Right, and then our last probability, winning $1, is 4 out of 8. And in this case, we won $1, but we spent $8, so we're going to multiply that by -7. This is going to give us 12 over 8 plus 2 over 8. Again, if we just multiply our top numbers, minus 6 over 8 minus 4 times 7 gives us 28 over 8. So then if we add and subtract, 12 plus 2 is 14. 14 minus 6 gives us 8. 8 minus 28 is going to give us a -20 over 8, which reduces to -5 over 2 as fractions, which then reduces to a -$2.50. So our expected value for this spinner game, right, is -$2.50. Now to use our formula from above, right, our fair price, right, is our expected value plus our cost to play. So in this particular example, our fair price is our expected value, which is negative $2.50 from part A of this example, plus our cost to pay, which is $8, which gives us a fair price. If we subtract these, 8 minus $2.50 gives us a positive $5.50. So once we have the expected value calculated, our fair price again is just a nice simple addition or subtraction. As we were going through all of the examples in this section, for the most part I chose to leave them as fractions and work with fractions that had common denominators to do my adding and subtracting. You may work through these however you choose. If you would rather change these into decimals, if you would rather do a lot of that type of work with your calculator, that is definitely an option.